Hi everyone. Today in this video we are going to see how exactly we can use stack data structure for postfix evaluation. So in last video we already discussed how exactly the given infix mathematical expression can be converted into the postfix expression by using stack data structure. Today we will discuss one more application of stack, that is the given postfix expression, how we are going to evaluate by using the stack data structure. So this is the algorithmic steps. So how exactly we can use the stack data structure for evaluation of postfix. In the first, you can insert the right parenthesis at the end of the given postfix evaluation expression. Now you can scan that postfix from left to right, and you can repeat these steps 3 and 4. So if operand is encountered, put that operand into the stack. So here we are going to keep all operands into the stack. So if one operator comes, then we are going to top out top two elements, and we are going to apply that operator on those two operands, and the result will be placed back into the stack. So this is the steps we need to follow for evaluation of the postfix expression. So we will see some examples so that you will get more clarity, and again we will get back this algorithm. So this is the postfix expression and we are having. Now I want to evaluate this expression and I want to find what is the final result of this postfix expression. So as per the algorithm, so I am taking some stack and I am adding close bracket to the postfix expression. Now I am going to evaluate this postfix expression from left to right, and whenever I am finding the operand, so yes, I got 3. So push that operand or value into the stack. Next 4. So it is operand. Send there. Now we are getting operator. So to evaluate that operator multiplication, I need to pop out 2 values from the stack. So first you can pop out the first value, so that is 4. Then your operator star, then pop out next value from the stack, that is 3. So 3 into 4. 3 into 4. So what is the result here? 12. So now you can send back this result to the stack. 12. Evaluate next 2. It is operand. Directly you can add for the stack. Next you can take next operand, that is 5. Send back to your stack. Now you are getting star. So you can pop out 2 values. What are those 2 values? 5. Then you can apply that operator star. What is the next value in this stack? 2. So what is the result? 2 into 5, it is 10. Send back this result to the stack. So on top of 12, now we are having 10. So what is the next symbol I am having in the expression? Plus. So it is operator. So again I need to pop out 2 values from the stack. So what are the 2 values I am having? 10. Apply that operator plus, and the next value is 12. So 12 plus 10, it is 22. So this is the result. Send back to the stack and the expression is completed. And this is your final result of your postfix expression. So this is how we can use the stack to store all the operands, and whenever you are encountering one operator, we are taking two values from the stack and we apply this operator to those two operands. We will calculate, and that result we are sending back to the stack. These are the steps we are following for evaluation of the postfix expression. So I will take one more example so that you will get more clarity. So this is the given postfix expression. 1, 2, 3 into plus 4 minus. So how we are going to evaluate this postfix expression? Take the stack, add close bracket here. So it is delimiter. So when you are reading that postfix expression from left to right, somewhere we need to stop. Okay, so this is the delimiter. So whenever I am getting this bracket, it indicates that your postfix expression is completed. So first I am going to read from left to right. So what is the first? That is the operand, value 1. So you can push onto the stack. You can push onto the stack. So what is the next thing? 2. So you can push onto the stack. 3. So you can push onto the stack. Now you are encountering with star. You can pop out two values from the stack. So 3 into 2. So what is the result? 6. Send back this result to the stack. Again I am getting operator plus. So pop out two values from the stack. 6 plus 1. So what is the result of 1 plus 6? It is 7. Send back this result to the stack. So now I am getting some operand 4. Now I am getting minus. So pop out two values from the stack. 4. Apply the operator minus and the value 7. 7 minus 4. 3. Send back that result into the stack and your expression is completed, and this is your result. So what is your final result? 3. So this is the output of your postfix expression. 1, 2, 3 into plus 4 minus. So when you are evaluating that expression, this is your final result. So this is how exactly the algorithm steps we discussed. So quickly I can revise. First you can add close bracket to the given postfix expression. Now you can evaluate from left to right and you can repeat this process. So whenever you are finding the operand, simply you can keep into the stack, and whenever you are identifying operator, so then you can remove top two elements from the stack. So A top element and B is the next element. So A first pop out element, then apply the operator, then second pop out element from the stack. So evaluate this and that result you are sending back to the stack. This is the steps only we need to follow for conversion of postfix expression by using stack. So this is program how exactly you can implement. So here I am defining some stack with integer data type because I need to push all the values there. So I am taking as integer stack, and initially I am taking top is -1 and I am taking the postfix expression here, and I am using push and pop. You know what is push and pop. So whenever you want to push some data to the stack, you need to use push, and whenever you want to remove data, we are using this function pop. So first you can read the postfix expression. Now you are evaluating that postfix expression from left to right. So here I am taking postfix as string. So automatically what is the delimiter for the string? Null character. So until I encounter null character, one by one character I am reading, and that character I am converting into the integer value. First I am checking whether it is an alphabet or not. So if it is an alphabet, the corresponding value I am reading from the keyboard, I am pushing into the stack. Then if it is not operand, so what we need to do, if you got any operator, I need to pop out two values from the stack. So I am taking first top element as operand 2, second top element as operand 1. Now I am checking that operator here. So if it is plus, I am finding operator 1 plus operand 2. If it is minus, I am finding what is the difference of operand 1 and operand 2. If it is into, I am finding the product. If it is division, I am finding the division value. So by using this switch statement, the corresponding operation I can evaluate here. So I am incrementing the I value for next character of the postfix. So finally, that stack will have the result. So I am going to print what is the final result of your postfix expression here, and it is your push operation. So how exactly we can insert data to the stack, and this is the pop operation or pop function where exactly you are removing data from the stack. So these are the steps we need to follow. So this is simple implementation of postfix evaluation algorithm by using C programming. The next application of stack is Tower of Hanai problem. So what exactly is the Tower of Hanai problem? So we will have some needle. It is source needle, and this is destination needle. So whatever the disk I am having, so this disk I have to move from source to destination. For suppose only one disk I am having, that disk will be directly moved from source to destination. There is no problem. So for suppose I am having two disks in the source. So there is one condition that all disks I can place on the needle in such a way that I can able to place only the small disk on larger disk. That is the condition, right? So now I am having two, and I cannot move two at a time here. So how exactly I can move these two? So I required some temporary needle here. So first I am going to move the small disk here, then I can move the capital disk here, then I can move the small disk here. So like that, here the number of disks I can increase whatever the thing. If number of disks are 3 or 4 or 5, and we are using this temporary disk and destination disk to arrange, and finally we are going to get the arrangement as it is what we are having in the source that can be placed into the destination. Coming to the algorithm. So it is very recursive algorithm, very simple problem. If there is only one disk, n equivalent to 1 means if there is only one disk, there is no problem, directly I can move from source to destination. I don't require any temporary needle here. Then if it is more than one disk, we need to follow. So here I am taking two recursive methods. So first what we need to do, if you want to move n disk from source to destination, on top n-1 disk, first I am going to move to the temporary, then I am moving n, that is the large disk, from source to destination, then I am moving all those n-1 which I am having on the temporary disk to destination. So this is the recursive algorithm we are having for the Tower of Hanai problem, and this is the code, simple code. So first you can read how many disks you are having in the Tower of Hanai problem, and you can arrange. There are left, right. Left is source needle, right is destination needle, and this C is representing your temporary pole. So this is tower, you can decide, and there are 4 values I am passing to the function, that is number of disks, that is n, and you are using poles, it is from 2, and this is temporary. And the same what I am having in the algorithm is defined here. So if there is only one disk, directly I can move from source to destination. If it is more than one, the same thing. First n minus 1, first I am going to move to the temporary, then I am moving the nth disk from source to destination, then I am moving all those n minus 1 from temporary to destination by using source as a temporary now. So when you are moving these n minus 1 disk from temporary to destination, the source is temporary now. Okay. So this is the recursive algorithm we are using for the tower of Hanoi problem. So this is another application for the stack data structure. How exactly we can use this stack data structure for implementation of the tower of Hanoi problem. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.